Right, in this video I will talk about two of the most popular risk measures. Right, the first one, number one, right? So as usual, I'm gonna let X denote the loss associated with an investment. The first of the two most popular risk measures is known as the value at risk, or in short, VaR, right? Capital V, little a, capital R. And is defined by the following. This is the notation and is defined as the infimum of the set of all U for which the CDF of X at U is greater than or equal to P, right, where P is a probability between 0 and 1, and Fx denotes okay. So this is the most popular risk measure, and this risk measure VaR is due to the American insurance company JP Morgan. It was developed by people in this company a long time ago, right? And the interpretation of this definition is as follows. So what it means is the following. So VaR P of X is the loss exceeded with probability 1 minus P. All right, so in other words, is the amount of loss that is exceeded with probability 1 minus P. So let me give you some example. Let me give you just maybe one or two examples. So example one maybe. Suppose so VaR, for example, VaR 0.99, right, is the value of loss that has a 1% chance of being exceeded. Right, there's the 1% chance of being exceeded, right? And example 2, if you look at VaR, say 0.999, right? So this is the amount of loss that has a 0.1, right? That means 1 out of 1,000, right? all right, 0.1 percent of being exceeded, percent chance of being exceeded, right? So another example, say example, say 3. So if you look at this, if you look at this, for instance, say 0.9999. So this is the loss that will be exceeded 1 in every 10,000 times, right? Okay, so if this loss is, say, less than, say, 10 pounds, right, then maybe, so this suggests that the loss that is exceeded 1 in every 10,000 times, right, is less than 10 pounds. That means it's very small. It's a very small loss, right? So in this case, it's okay to invest. All right. Whereas the same loss, say for example, 0. Let's look at it. Okay, look at the same loss, say this one, which is the loss that is likely to occur 1 in every 10,000 times. If it is greater than, say, 1 million pounds, then it's better not to invest, because the chance of having something more than 1 million loss, right, once in every 10,000 times is still formidable, right? So it's better not to invest. All right. So that's the interpretation for VaR. All right. And so far I have talked about the most popular risk measure. Now the next thing I'm going to talk about is the second most popular risk measure, which is called the following. It's known as the expected shortfall, ES for short, and is defined by the following formula. It's a really complicated formula, so just bear with me, just be patient, and wait till I complete it. So it's 1 over P times the expectation of X plus P times this minus VaR P okay. So this is the formula for the expected shortfall, right, where the I function, you might have seen it before in previous courses you've taken, is known as the is known as the indicator function. I mean, just to remind you, in case you haven't seen it, or you have seen it but you don't remember, it's known as the indicator function, and is defined by the following. It takes two values, 1 or 0, 1 if A is true, and 0 if A is false, right? Okay, so this is the definition of ES. Now, ES was developed in the 1990s and is due to right. Okay. Now let me give you an interpretation of what ES actually means. All right. So this is the interpretation. The expected shortfall with probability P of the variable X has the following meaning. It is the average loss provided that the loss is less than or equal to VaR. Right? So it provided that the loss is less than or equal to VaR. What is the average loss? And that's given by this measure here. Okay. So a couple of examples. So example 1. So the ES at 0.99 of the variable X is the average of the losses not exceeded with 1% chance, right? And example 2, ES at say 0.999 is the average of the losses right, is the average of the losses not exceeded with 0.1% chance. Okay, right. Now the next question I'm going to ask. So I introduced two of the most popular risk measures. Number one is the value at risk, or VaR, and the second one is the expected shortfall, or ES. Right. Now, of these two risk measures, which one is the better? Now, in order to answer that question, I'm going to phrase the question like this. Remember, in the previous video, I talked about the definition of a risk measure and the definition of a coherent risk measure. So the question I'm going to ask is the following. So, both VaR and ES are risk measures, but the question here is whether they are coherent risk measures. Remember, for something to be coherent, it must satisfy, from the previous video, you will see it must satisfy 5 properties. The first property is the normalized property. The second property is the translative property, which any risk measure must satisfy. So is the normalized property. And the third property is the monotonic property, which any risk measure must satisfy. The fourth property is the positive homogeneity. Positive homogeneity property, and the fifth property is the subadditivity property. So the last two properties are satisfied only by coherent risk measures, right? Now I'm going to ask the question, right? I'm going to put VaR here, I'm going to put ES here. Right. Now I'm going to ask the question whether how many of these properties are satisfied by VaR and how many are satisfied by ES. Well, the first three must be satisfied by both, because both these are risk measures. Right? Now, positive homogeneity, it can be proved that VaR and ES satisfy positive homogeneity. Subadditivity, unfortunately, VaR does not satisfy subadditivity, but ES does satisfy subadditivity. So what this means is the following. That means VaR is not a coherent risk measure. Right, but ES, the expected shortfall, is a coherent risk measure. Right? So in this regard, the expected shortfall is a better measure because it is a coherent risk measure, while VaR is not a coherent risk measure. And the proof, later on in a later video, I will show you how to prove these 5 properties, right? Okay, but before that, let me show you some pictures now, because you may remember that there was a big financial crisis. There was a big financial crisis in 2008, and after a lot of people lost a lot of money everywhere, in every part of the world. And after the crisis, there were a lot of newspaper articles claiming that the crisis was due to VaR, because a lot of companies, including the big companies like JP Morgan, Wall Street, they were using VaR as the risk measure. before 2008. So, but it turns out that, as I explained here, VaR is not a coherent risk measure. So there were a lot of so that means that they were thinking that one of the reasons that the crisis was so big, affecting nearly every part of the world, was because of the fact that these companies used VaR, which is not a good risk measure. And I will show you some articles. I will show you some articles now. Like this is one of the articles that came out after the crisis. It says that VaR, the number that killed us, right? This is another one saying that what did value at risk cause the crisis? It was meant to avert, right? Okay, and this is the same thing, same article here. Did value at risk cause the crisis? It was meant to avert. And finally, this one, value at risk and its role in the credit crisis of 2008. Okay, so these are some of the articles that were published after the crisis. Blaming VaR was one of the factors for the crisis. And so since 2008, there have been a lot of work in the academic world, especially in the financial community, trying to develop new risk measures that are better than VaR. Okay, and so you see that nearly every university in the UK and elsewhere, they now have programs, master's programs in mathematical finance. And so mathematical finance is a big area, but one of the things you can do using mathematical finance is to develop new risk measures. So that's one of the key aims. And these programs have evolved only after they have evolved mainly after the credit crisis of 2008. Okay. In the next video, I will talk about the two expressions that I gave you for VaR and ES. They are not the most easiest expressions to work out. So in the next video, I shall talk about some simple expressions for VaR and ES.